All right, it looks like that is going to be most of our attendees for today. Thank you so much for joining us, and welcome to the USC Viterbi Civil and Environmental Engineering Department Faculty Roundtable. We have faculty from the Sunny Estani Department of Civil and Environmental Engineering at the USC Viterbi School of Engineering joining us. My name is Paul Ledesma. I will be the moderator for today's discussion. I am the Director of Undergraduate Admission at the USC Viterbi School of Engineering. It's a pleasure to see all of you here. I'm glad you're here. A couple kind of ground rules for today's session. We're going to go about an hour. And we're going to discuss the department, the discipline, the curriculum, our faculty, more about them and their research, and hopefully some of these fun questions that you guys have asked as well. And we're going to open it up to your questions and answers towards the latter half of the session. So please hold your questions for the time being. We will get to those questions at the end, and just hold those questions and we'll deal with Q&A at the end. But without further ado, we're going to allow our faculty to introduce themselves and tell us a little bit about themselves and where they come from and what they do at USC. We'll start with the department chair, Dr. Lucio Soiboulin.
Hello, everyone. Welcome to the Department of Civil Environmental Engineering. I am a professor and the chairman of the department. I am originally from Brazil. I have my degrees, my undergrad degrees in civil engineering from a university in Brazil. Got my master's there, worked in Brazil in industry for 10 years, and came many years ago to the US to get my PhD. And I've been working in academia since I got my PhD at MIT. I focus my research on the interface of computing and civil engineering, working with analytics and big data for better decisions and design and operations of civil and environmental engineering systems.
Thank you. Dr. Childress. Oh, you're muted.
All right, I'm Amy Childress, professor and director of environmental engineering. I'm from Maryland, went to University of Maryland undergrad, got my PhD from UCLA, and I research on membrane processes for wastewater reclamation and desalination.
Awesome. Dr. Ben Weiss.
Hi there, I'm George Bonweiss, and I got all my degrees actually from UC Berkeley. I've been at USC since 2013, and my research focuses on climate and air pollution, and have a focus on aerosols, particulate matter. It's been a really interesting time to be an aerosol researcher, given all the wildfires and the implications of aerosol transmission with COVID. So it's been very interesting with aerosols probably being more in the news than ever before. So we can talk more about that later.
And last but not least.
Hello, everyone. I'm Bora Gençtürk. I'm an associate professor in the department, and I'm also the director of our Structures and Materials Research Laboratory. I was born and raised in Turkey, so my undergraduate degree is one of the best engineering schools in Turkey, which is Boğaziçi University. Then I moved to United States and got my master's and PhD degrees from the University of Illinois at Urbana-Champaign. And I was a professor at the University of Houston for 5 years before joining to USC in 2016. So my research is mainly on construction materials. So I look at high performance materials, mainly cementitious materials, but also some metals. So we do a lot of materials and structural research, including durability of infrastructure, aging infrastructure at USC.
All right, thank you, Dr. Gençtürk, excuse me. We are excited to have all of you here today. We have a fantastic audience today, all prospective high school students and family members that are looking at this discipline as something that they might be applying this coming year for fall 2021. And thank you for sharing your poll answers with us today. It looks like a majority of you are in the Pacific time zone, but it looks like we're covered almost across the country, and we have a few international students as well. And we've listed out all the disciplines, and it looks like there's some good balance between all the different disciplines, if you all can see that, based on what students want to study. And we're going to hit that question in just a minute. As far as what you want to learn today, We're going to get into this type of information right off the bat. This helps guide our questions. And I love this fun question. So faculty, if you don't see that, be ready to answer this fun question at the back of the back session of this. But why don't we get started with what seems like a simple question, but probably one of the most important for our students and parents in attendance, which is, what is civil engineering and what is environmental engineering? Maybe one of you can handle civil and another can handle environmental, or please jump in. Another thing I'll say is, go ahead and keep your mics unmuted if you're able to, because then you can keep talking over each other, and that's always more fun.
So I can start. I would start with civil, and I would get Amy talking a little bit about the environmental side. But civil engineer, it's the professional that does a lot of things related to the built environment. Okay, so we go from the design and construction and operations of every systems that we interact in our daily life. So buildings, it's one example, but when we think about transportation systems, we go from the construction of the bridges, the pavements, the roads, but we design the time that it takes from red to green to yellow. You optimize those systems. So this is part of the civil engineering profession. We work with soils, geotech, earthquakes. We design the foundations of buildings to deal with extreme events, with hurricanes. So you have the water distribution systems. The civil engineer, it's responsible for building the water treatment plants, the physical part, and the environmental engineer, it's much more responsible for how the civil, it's much more about the vessel and how you maintain and transport the water, but environmental engineering treats that water. So almost everything that we interact in our life has something related to one of the expertises in civil engineering. Amy can add in the environmental side.
Okay, so yeah, environmental engineering is the engineered side of processes, maybe to remediate pollution, air or water pollution, but there's also a natural systems side of ensuring that the water quality or air quality that we're subject to is good. And so at USC, you can either study environmental engineering kind of separately, or you can study environmental engineering within the civil engineering degree. And I think that's kind of an important differentiation. If you like the infrastructure and the more systems approach, then environmental within the civil engineering degree could be better. If you're more interested in some of the basic sciences, the biology and the chemistry, then the environmental route is a little bit more basic science versus, but there's still a very strong engineering component, but just not that civil infrastructure, large scale component of the civil engineering side. Did that make sense, George?
Perfect sense. Yeah. I don't think I have much to add, but I do agree that environmental engineering, what I actually really like about it is that it straddles sort of understanding the systems. And so that means, just understanding how the chemistry behind air pollution, or the physics behind airflow, or land air coupling, or there's some sort of basic science to be understood, which then gets you to be able to find solutions to environmental problems. And a lot of those are engineering solutions. And so you can sort of straddle the sort of more basic science, understanding the system, and the engineering, finding solutions to the problems in environmental engineering in general. And then, yeah, again, the civil engineering degree with the environmental emphasis gives you more of that sort of infrastructure side of things as well. Although you still get a lot of environmental engineering too. So
you guys, in the end, you sound very like our dean in engineering here, that when he uses von Karman to explain the difference from a statement from von Karman, explaining the difference from systems and for science and engineering, that science describes the world as it is, while the engineers creates the world that never was. So you are more or less saying this in different words.
Absolutely. Dr.
So,
Gensch, oh, sorry, go ahead. Please.
Yeah, I was going to ask Bora to add any other thing that I missed in the civil side.
So maybe I may add that, one other aspect that we also control is the processes. We are involved in design, but also the processes such as the construction. Lucio, for example, Dr. Soberman works in the construction management area, which has to do with the costing and all the the construction sequences and the phasing. It's not just about designing the actual structure, but it's also about the processes that gets involved in not just in the construction process, but also beyond the construction and throughout the lifetime of the structure. We get involved when it is repairs and maintenance and all those things. So I just wanted to mention that as well.
Fantastic, thank you. Also, if you all could please hold your questions for the time being. There will be plenty of time for Q&A toward the end, but just hold those questions for now. I'd like to add a follow-up question for both Amy, for Dr. Childress and Dr. Benweiss, and the idea of environmental engineering. A lot of our students are interested in things related to the environment, and maybe they've taken environmental science in high school and they see the opportunities to look at environmental engineering in college, but they also see other programs across universities that have the word environment in it, like environmental science or environmental policy. Can you talk about the differences between an environmental engineering degree program and something that's much more outside of engineering?
Sure, I'll let George start.
Let's see. Okay, so I would say, there are environmental engineering degrees, there are environmental science degrees, which are typically outside of engineering. There is a program at USC that's environmental science. There's environmental studies, and then there can be other environmental degrees as well. Environmental engineering is generally speaking the most technical of the degrees. So you're going to be taking physics and chemistry and math for your first couple of years, and all of your engineering, well, not all, but most of your engineering classes are going to be sort of building up your toolkit to be able to be employable as an environmental engineer. Environmental science, I would say that degree really varies depending on the university. But environmental science and environmental studies degrees tend to be a little bit more qualitative, I guess. They can be really good programs, but the thing I think to look out for is to make sure that they're not closer to like a humanities degree, if what you want to do is technical stuff, because you end up not learning the fundamentals and the building up, your sort of technical knowledge to be able to do a technical job. And so I would say that's the main difference, and environmental engineering, at least in our program. Again, what I like is you get the sort of basic science part, but then you also have engineering knowledge that you learn. And so it's a little bit of a difficult question to answer, because I think environmental science and environmental studies can widely vary depending on the university, but just look out for them being sort of not technical enough, if being technical is what you want.
Nowhere near as technical as an engineering degree or creating of technology, I would say.
And I would add to that in the environmental engineering program, George, you mentioned employability. We do not have any problem getting our students hired when they graduate. Most of them, well, I won't say most, I don't know the breakdown, but if they want to go straight into a position, they easily can get a job. If they want to go to grad school, that's fine too.
Absolutely, cool, thank you.
But I think employability a bit, oh my gosh, I still can't say it.
Employability.
Yeah,
between you and me, Amy, we can say everything. I'll say that one, employability.
The marketability of the degree, the opportunities for future employment and salary, to be quite honest with you. So that's fantastic. Thank you. Can we expand a little bit more on the curriculum? Let's start with the undergraduate degree offerings, because there are a number of different degree offerings, and we've listed them in that poll for students to see. Can we describe the differences between these programs? Because we have some unique opportunities here for undergraduates.
So the curriculum, one thing interesting is to talk a little bit before the curriculum. It's to talk about the department. This department is the department that has been changing very, very fast. I came here as chair in 2012, so this is 8 to 9 years ago, and we did hire. Now we are hiring another 2 faculty this year, even with the hire freeze. So we hired with everything around 14 full-time faculty. And we went last year through a huge exercise of rethinking the curriculum, because the world is changing, but because our faculty is younger with new ideas, and you wanted to be able to optimize the curriculum to what we are really good at. So match the curriculum to the new amazing faculty that we hired, and getting a younger perspective into civil engineering problems with the younger faculty and all the things that you have. The curriculum, when you see all those options, those are basically small changes from one to the other one within the civil side, all the options that you have, because the large majority of the first, second, and third year, the classes are almost the same, and what you have in the specialization, if it's structures or constructions, are a small number of classes that you take that would give you a deeper knowledge in those specific areas. But the curriculum is, as George was saying, we are building the building blocks for the student to be able to solve the problems that they're going to have. And then at the end, we introduce them to the types of problems in that each one of those specific areas. The only one that is a little bit more different is the building science curriculum. That's very unique to USC, because building science is in a hybrid with civil engineering and architecture. So our students take the traditional curriculum in civil engineering, but they have to take around 12 units of classes in architecture on top of that, with a complete different ways of content delivery that the architects do so well, with the studios, exercises, working the design, and so the students get a lot of interesting job offers, because it's basically a professional that doesn't exist in the US. Companies really, that when they want someone with that specific expertise, they have USC to hire those students. But the others, yes, you have all those areas, and I thought that the curriculum is not very different. It's where you apply the building blocks that you learn during your first 2-3 years into the problems that you're going to try to use that knowledge to solve, either in construction or in the structures and the other areas. In the environmental engineering side, in the civil engineering, environmental engineering, and the environmental engineering, I would let Amy and George talk about the curriculum. And then Bora, that it's a part of the curriculum committee, can talk a little bit more about the civil side.
Okay, so I'm not too sure what to add. I think I touched on it already with, if you go the pure environmental engineering route, you get more of the chemistry, organic chemistry, but we've softened that, so it's not anything to avoid. Biology, but if you go more the civil route, you get the underpinning and statics and some of the mechanics that I think's important for that infrastructure route. So there's for all of the programs, we try to keep the first year the same so that students can come in and have a little bit of movement if they decide where they came in is not the exact right program for them. I don't know, Bora, do you want to add anything?
Yeah, I may say a few things about the curriculum revision, in the sense that when we were working on this revision, we were focused on how we can introduce more new things into the curriculum. And I think we have done a good job in that by removing some of the redundancies we have in the courses. So some redundancy is obviously good because you want to solidify certain concepts. But what we have done is that if there's too much redundancy, repeating the same topic from one course to another course over the many years, over the 4 years, we removed some of those redundancies. This allowed us to introduce newer concepts, more like research-oriented things. And I think it gives the students a better perspective to understand the real world and what they could face when they graduate and go into their next step in life, whether graduate school or professional life. So I think that we did a good job in that regard to introduce other things, other concepts into our courses.
That's great. Can we flesh out a little bit more on the ideas or on the balance of theoretical coursework and hands-on coursework throughout the undergraduate curriculum? What's the department's approach, and what are some projects that students can expect to find in their undergraduate years studying one of these disciplines?
I would say that what you have, everything that it's design, class as the title in design, we use top people from industry as people from outside to help us teaching, because bringing that experience in design is extremely important to our students. So, and those professors coming from industry, where the students have, basically what I'm trying to say is that the academics, we provide the building blocks, the mechanics, the statics, the chemistry, the biology, all the building blocks needed for the student to be able to solve the engineering problems. But when they are in the more senior years, when they are doing the capstone designs, when they are doing the design exercises, we bring people from industry to help them that have experience of doing this for many, many years. Other thing that we have the concept that we call professors of practice. Those are full-time professors that bring many, many years in experience in the construction site. We have Hank Kaufman that owned the construction company for many, many years, and he brings that expertise to the classroom. In the structure side, you have Greg Brandel that was the president of Brandel, Johnson Brandel. That's probably the biggest structural engineering company in Southern California. So he sold his participation in the company, and he provides full time to the department. We have Amy Richmacher with the geotech. So we do understand that practical experience to teach what happens in industry. It's very, very important, and this is part of our curriculum. Our students being in a big city like LA, it's another big advantage of USC. If you compare to universities in the middle of nowhere, that's very common to top engineering schools, those state universities being those college towns. We have a huge advantage that we have LA around us. So the top engineering companies are 2 miles away in downtown LA. So many of our students have a lot of opportunities for internship. And many of our students, after the internships, even in their senior years, they keep partial jobs with those companies and developing applications in the real world while they are learning the theory.
Any other ideas or things related to hands-on projects that students might come to expect, or that you go through that students enjoy as favorites?
In environmental engineering, we have a design course, like Lucio said, that is taught by somebody working in the field. And that's really great, because then when they have opportunities for internships, they reach out to our students. And then when the students are looking for jobs, they obviously don't hire all of them, but they're willing to look at resumes and provide feedback. So it's good connection to have.
So other thing that you have that's pretty big at USC is the student clubs. For example, in the civil side, we have very active groups in the CMAA, Construction Management Association of America, that they have a huge competition that happens once a year in Reno, Nevada. And we send 2 buses of students to that competition. We send 7 to 8 teams there. And those teams prepare a whole year for that competition. Normally, their mentors, normally not all their mentors are people from industry. That's what I tell, that's an advantage of being a big town. People are here, they come after their work, they mentor our students. Their objectives is to meet the top students to hire, but at the same time, our students are being mentored and trained, not just for classes, but to extracurricular activities while they go in those competitions. And they have a lot of interaction with the industry, either for competition, internships. We have so many options for those students related to get more practical experience.
It's definitely a very tight-knit community inside your department. The students, the faculty, the alumni, everybody seems to know each other. Everybody works really closely together, and it just fosters a really nice community. And I think that's built out of the coursework. It's built out of the student design teams and student organizations. And then, of course, that permeates their industry. You're absolutely right. Can we talk a little bit more about, or switch gears a little bit more towards research? I know that there are some specific areas of research that are targeted in the department, but also I'd like to hear about individual research focuses from each of you.
Okay, I can start with the 4 main areas that the department strategic planning and where you, the areas that you really have a lot of expertise and research. The first area, it's the extreme events area. So Bora, it's a faculty working that area. The extreme events looks into earthquakes, tsunamis, and other extreme events, and how we protect and you understand how to build and design and fix things or deal with those events. This is getting every year more important because with the changing climate, those extreme events are getting more common and they're getting more severe. And the way that we design our standards and the way that we consider those events affecting the infrastructure is now changed very, very fast. The second area that we have is the sustainability area. We have a lot of very strong work, both in the civil side and in the environmental side in sustainability. We have top work in air quality with George and Costas and others, but we have a very, very strong sustainability work done in water energy nexus and even in the civil and building with me and Burchin working energy on buildings, improving energy efficiency. A lot of interesting work in this area. The third area is water, that Amy is in the water area. And the idea is really drinking water. And this is so important to deal in Southern California, wastewater and drinking water. That is known to be one of the biggest problems that civilization is going to be facing the next few years. And the final area, it's an area that it's very unique to USC that we call it systems of systems. One thing that it's interesting in civil engineering, it's that we got specialized, dividing ourselves in silos of expertise. So you have the transportation engineer, you have the construction engineer, you have the electrical engineer doing the grid. You got designing those systems as independent. So the water distribution systems. So if you think in a city, your people that design the water distribution systems to get water reaching your house, they optimize that system to make sure that the water arrives in your house. But the people that do the transportation systems design the optimal system to allow you to drive and move in the city, but they are designed as independent systems, and they are not. When you have a water main break, a part of the water systems breaks, you flood the highway. So both systems stop operating at the same time. So things are coupled. and very complex, and you really need to understand the interface of those systems. And you have very strong group looking into complex cities like LA and how you optimize the city as a whole, but not individual components of those systems. I will let them, they talk about their research, and if you have time, I talk about my research later. So we can start with Amy talking about the water research.
Okay, so me, Dan McCurry, and Adam Smith, that's two other faculty in kind of the environmental group. We work on the topic of water reuse, taking wastewater and essentially converting it to drinking water. Something we do a lot of in California, we do a lot of in Texas, but also on the East Coast. There's a big project, several projects in Virginia, other places. And so we kind of come at it from different sides. I'm more of a process person. I'm, like I said before, a membrane person. Dan McCurry brings in the aquatic chemistry. So he quantifies the known contaminants in the water, and then I tries to identify the unknown contaminants. And then Adam Smith does more microbiology and biological processes, membrane bioreactors, that type of thing. So we kind of have a strong core in water reuse. I also do some desalination as well. And then I collaborate with Kelly Sanders. So Kelly does big picture energy water. And so her and I have had a few projects where we look at something called demand response for energy systems. So can our water treatment plants take up that additional energy when it's available, so we don't have to give it for free to Arizona or something? And George, you also work with Kelly and do your own research, so maybe you can segue there.
Sure. Kelly and I have co-advised a few PhD students. That work sort of brings together her energy expertise and my climate expertise, and we're looking at, in a nutshell, how climate change is expected to increase residential energy use into the future. We've done some other work that has used smart meter data. We got a really big smart meter data set for hundreds of thousands of homes in Southern California. And we're able to do a bunch of interesting analyses with those, looking at things like developing a technique to determine who does and doesn't have air conditioning. And so can make connections. Sorry, you don't? Yeah. Yeah. So make connections between, baseline climate, like if you live on the west side of the basin, you're less likely to have AC, but then also connections between various socioeconomic factors and air conditioning prevalence, and then vulnerability to extreme heat into the future. So we've done some fun work on that. And then more generally, my research group focuses on various aspects of air pollution and climate change, which are two of society's big environmental challenges. And so we look at how climate and air quality and land cover interact at various scales, look at neighborhood scale, we do neighborhood scale studies. Most of what we do is urban scale studies, but even some global scale studies. And then also do research. So that's a little more on the fundamental side of things, then also do research using what we learn about the fundamental things to try to investigate sort of practical solutions for mitigating climate change and reducing air pollution in urban areas. So some examples are, well, something that we're working on now. I guess I'll describe what we're working on now, and then a little bit about what we've done in the past. So now we're working on some studies to look at what are the air pollution co-benefits of various renewable energy pathways into the future, right? So as we adopt renewable energy, one of the main reasons for doing so is to reduce greenhouse gas emissions, which mitigates global climate change. But then there are huge air pollution impacts, like local urban air pollution benefits as well. And so we're looking into quantifying those. And then we've done a bunch of work on what are called heat mitigation strategies. So looking at various ways in which cities can reduce temperatures in the face of urban heat islands and climate change into the future. So I've done quite a bit of work on that using climate models and satellite observations and ground measurements and various tools. And then some work also looking at air pollution emissions, different air pollution emission sources. So we're just wrapping up a project now where we did a bunch of measurements down at the Port of LA to quantify some important sources down there of pollutants that hadn't been well quantified yet, to try to help sort of target policies that would have the most effective air pollution reductions for the lowest costs, basically. And so those are a few examples of the types of research that my group does.
Dr. Genster.
So yeah, I'm more on the structure side, materials and structures. So we have a bunch of faculty on the structure side. I particularly am more on the experimental side. So we have a decent size and a brand new structural testing lab, materials and structural. So I look at different construction materials, new and high performance construction materials, such as, concretes that don't crack or concretes that go very high strength. We are doing work on self-healing materials. These materials basically don't need any repair throughout their lifetimes. I involved, and I still do that. Unfortunately, with the COVID, our lab has been closed for a while, but prior to that, and hopefully in the future, we have a lot of undergraduate researchers working in our lab. So I really enjoy working with undergraduate students in the lab, and they learn a lot, I think. So my research is basically that, briefly, but there are other faculty members in our department who are also doing research on the structure side. Sami Mazri, he is mainly focusing on dynamics of structures. So he's more on the earthquake side, looking at the dynamic vibrations of buildings and bridges. Similarly, Eric Johnson, he is also our vice dean. He also has a similar research area where he looks at dynamics of structures, developing theories for controlling and reducing vibrations during an earthquake, structural damping systems, and so on. We also have another faculty member, Roger Ganem. He's also on the structures mechanics side. His research is mainly on the probabilistic quantification of processes and also mechanics, probabilistic mechanics. He does a lot of research on uncertainty quantification and so on. We have another faculty member. His name is Kiming Wang, and he is at I think in between the environmental engineering side and the materials. He's developing very interesting, basically structural. How to describe it, like structural connections or some materials that have special characteristics, such as negative thermal expansions and so on. If you heat a material will tend to expand. The types of materials he's working on, you call them metamaterials, that basically shrink when you heat them and so on. So he's also doing very interesting research in those areas. So it is very briefly, that's what, if you want to cover the research on the structure side, that's what we do.
There's definitely a lot, and I'm sure we can spend a lot of time on that. Lucy, are you okay if we move on to another question?
I think yes, sure.
Okay. So in the areas of things that you all wanted to be answered, we covered practically everything. One thing that was on the topic was admission information, and we will not be covering admission information in the session because we have our faculty, and it's great to hear from them. If you are interested in learning more about admission and the application process for undergraduate, for either first-year students or for transfer students, I'm putting a link into the chat right now where you can sign up for a specific session where we'll go over all of that information. So please find that. Register for one of our information sessions. We'll be able to handle that. The last thing that we didn't cover is the fun question. And so I'm going to ask you this fun question, everybody, and then we'll get into Q&A from all of our guests that are here. So if you weren't an engineering professor, what would you hope you would be doing for a living? Who would like to answer?
George is the one that has a dual life, so he can answer because he does both. Okay.
Yeah, that one's easy for me. I would be a musician, and so I play bass, and I would call my bass playing semi-professional. I
Very cool.
I play shows. I get paid for them. So that's the definition of professional, right?
Semi-professional. Tell us the name of the people that you played with.
Well, now I'm playing in a band that's called Paco Versailles. Who the guy who started that band is the same guy who started this band called Capital Cities, which had a pretty big hit called Safe and Sound. So so that's a fun band to play with. And then I played for 7 years. This is back when I lived in the Bay Area. I played for 7 years in a jazz group with this guy Mads Tolling, who is a 2-time Grammy Award winning violinist. That's a few examples.
That's fantastic. Very cool.
So now me, Amy, and Bar
No one can top that.
say anything. No, we cannot top that anymore. Okay. I'll do my best to do.
Any dream jobs from back in the day when you were kids about what you wanted to be?
Truck driver.
A truck driver?
Cashier.
My aspiration was to be a bus driver. Lucio, we're very similar. That was my favorite thing.
Truck driver or bus driver? Really? Those were both of your like aspirations?
Well, when I was 4, yes.
Okay. It's just the big machinery probably, right? It's just out there like managing that big machine.
I loved buses. And then I wanted to be an airline pilot.
Yeah, even if I'm a civil engineer, when I was 14 years old, my dad bought me 2 army jeeps that would not operate and told me that if I could make one of them, I could drive them. So at 14 years old,
full-size jeeps.
Full-size jeeps, I grabbed them, and from the 2 I made one. Only things that he told me that I could buy was battery, tires, and the carburetor. Everything, and the wiring. Everything else I had to transform from the non-operating jeeps and make them work. Took me 1.5 year working, and I had them when I was 15 and a half. It was going, and but to drive in Brazil, you have to be 18. So I had that thing for a while and couldn't drive.
Definitely sounds like a mix between one of our engineering classes and one of these design competition shows. Like, here are the rules. You only get so many things. You have to make it work. Well, let's get to our Q&A. We have an audience with some questions here. And the first question is for Dr. Childress. And so I'd like her to answer is, how does it feel to be a woman in engineering? And what problems have you faced regarding the matter? And maybe you can speak not only to your experience, but to our current female student experiences as well.
I'd like to toss this one to George and let him start, but I guess I can't. Sorry. That was only because, if I want to think about something, I've been tossing.
Yeah, no, that's been your out for the whole session. Like, George, kick it off and I'll clean it up. Yeah, this one doesn't.
No, but I can say something. Our department, the majority of the students in the department are female students. Much more than 50%, both in civil. I think that the freshman class in civil was around 65% female students. And in environmental, I'm not even going to say because it's almost too much in the numbers. So it is an area, both civil and environmental engineering, that I don't see a lot of resistance to women. You go in construction sites here in LA, top construction managers are women. I have 3 sisters older than me. They're all owners of construction companies, and they never complained of issues and difficulties. But I think that Amy, if you live it and if you have anything, you can.
That's good. That gave me some time to think about it. Things that like you're saying, things are definitely different now than they used to be. But to be honest, I have not had a lot of challenges in that way. Maybe in past more historic times. There have been, but in recent days, there's, we have 3 female faculty in the department, plus a couple more teaching faculty.
You hired another one now.
Yes, and we're in the process of hiring another one. That's good. So I feel there are plenty of times that I leave the department or I leave environmental engineering and I'm in different settings. And I do still experience things sometimes in those different settings, but I'd say at USC and in general in the field of environmental and also in civil as well, it's maybe not such a big deal anymore.
Yeah, it's definitely a different world. School-wide, we reached gender parity last year in our incoming class. This year, we were about 48% in our incoming class. And as Lucio noted, the incoming class for civil and environmental this year was a little more heavily tilted toward women. And it kind of balances out each particular year. But we're target for the school, and our kind of operating structure is 50-50. So it's very different than a lot of other engineering environments that are out there. Hope asked the question. It's a little wordy, so I'm going to read it out, and you guys can interpret the best way to go. But she's more interested in designing buildings and engineering while continuing in sustainable studies. Should I go into civil engineering with an environmental focus or civil engineering building science? Do you think I'll have broader or smaller, quote unquote, environmental engineering fieldwork with a civil engineering building science degree? So really, this is a typical high school question, right? There's so many options. I don't want to pigeonhole myself, but I have interests that overlap between these areas. What should I be doing?
I would recommend building science because
For sure,
it's in.
Yeah.
Yeah. I would recommend building sciences because there is a lot of sustainability in the faculty in building sciences. They are doing a lot of sustainability work, and because this is the one for designing buildings. If you're thinking about designing other systems like water distribution systems, highway systems, then I would go with civil and with the environmental background. Depend what you want to design. If it's really focusing on buildings and green buildings and those kinds of things, I'd go to building science. And the advantage is that it's easier if you realize later that it's not exactly what you wanted. It's easier to move from building sciences to back to civil or to environmental than the other way around, because building science is the one that has this extra criteria of classes together with architecture.
Yeah, I was about to say in the question, Hope, thank you for your question. You kind of answered in your first sentence saying, I want to design buildings. And so that's the answer to the question, what you want to do. And this goes into another question that was asked by Caddy. It says there's so many subfields. How do we decide which one is for us? And no one can tell you what it is that you want to do. And so when you hear the faculty talk, you'll notice there is a lot of overlapping areas. And how Dr. Sobelman mentioned, they're coupled, they're interconnected, and it's complex. And at the end of the day, professionals in engineering, even outside of this discipline, all work together to solve problems. So if you're confused, I would work more on the back end, reverse engineer. What is the problem you're looking to solve? What's a passion of yours? What's interesting to you? And then start narrowing it down from that level. And then the link that I also put in our chat earlier about the disciplines, you can review the degree course outlines and see the differences in how the courses are taken and see which one might be right for you. Finally,
but just to add something, I don't think that this is a very important and relevant question in the way that it's very easy to move from one to the other one. So if we start, and again, one thing that you have in your freshman year, it's freshman academy and introduction to civil engineering, or introduction to environmental engineering. So you are going to be exposed with much bigger depth that you are doing here in 1 hour to what it's really all those sub areas, and you can always move from one to another one. So I would not be concerned now. I would be arriving and talking and taking classes. Those things are going to and even later you have students that decide one area, and then the first summer they go to internship and they come back and say, not that. I want something else, or they were thinking one area, but by luck they got internship in another area and they realized I loved it. So it's very easy to move around and find your passion after you're here.
That's exactly where I was going. So you read my mind. Yeah, in the admission process, you're not locking yourself in. Choose something that sounds interesting. It's a flexible program. You can change as you go. And engineering, and even I think the main answer is it's an experiential process. You got to start going through it to figure out what you like, what you don't like. You can't figure it out from the outside looking in. Arlette asked an interesting question: is that do you have any research going on related to the recent wildfires? Is there any research going on in that area related to civil and environmental engineering?
We have one professor that has expertise in this area. He's a tsunami professor, but he works with extreme events, and he has been writing some interesting articles on fire. He's by coincidence that this year that I have all those fires, he's on sabbatical. But in the last year, when you had the fires, and that it's happening every year, he did work a little bit with some agencies trying to predict, to model the path of those fires. So he was using mathematical models to try to tell them which direction the fire was going to move. So we do have people working much more on the computational side on modeling the behaviors of those extreme events.
I can speak briefly too on the air pollution impacts of wildfire. Both my group and another colleague, Kostas Siotis, we both work on a lot of things related to aerosol emissions and aerosol health. He works on aerosol health impacts. One of my PhD students is just finishing a study. We were looking at not this year, but the 2018 wildfires, and he did a bunch of measurements of wildfire emissions and basically using the measurements from wildfires that were in Southern California and also in Northern California, which we could detect all the way in Southern California. We did measurements off on a remote-ish island off the west coast of LA, Catalina Island, and basically did a study looking at how aging of these wildfire aerosols affects their climate relevant properties. So that's wildfire related.
That's helpful. Thank you. I know, Dr. Childress, you're going to have to step out any minute now. And so feel free if you need to at any point. I know we're running a little bit, and we're going to start wrapping this up. I'm going to go through a few questions, rapid fire, super fast. Daraja asks, how many students participate in research or internships through the undergrad experience? I've never known of students that haven't had the opportunity to get involved in research if they wanted to. I'm assuming you all have undergrads involved at some level in your labs, and you know of other faculty? Yes. Not.
Yeah. Yeah, we have more option for research for undergrad students than undergrad students offering themselves to do research.
You need more. Yeah.
We need more undergrad students because, as I said before, the city has all the industry, and majority of these students are getting very interesting internships, and they by research internships, so many choose internships, and you have more positions for undergrad research than you have students wanting to do it.
Absolutely. What do you see the future of civil and environmental engineering going?
I see it very clearly, but I'm talking too much. So anyone else wants to say it? Say anything?
I'll say better integration between our natural systems and our engineered systems. I think we might do more water treatment outside a building where with a fountain or things that you can see, not just tucked away in the basement of the building yeah.
Maybe I can add extraterrestrial occupation. Like if we were to, build some bases on the moon or travel to the Mars and so on, construction at those places, civil engineers will be heavily involved, material scientists, construction materials, research, and designing and building in those environments will be a completely different thing, with the environmental conditions and the materials and so on. I think that's going to be a very interesting thing in the coming years.
As I said before, I am a computing in civil engineering guy. I see the AI and the change in the knowledge world with a lot of work moving from memorization and things that we know to that it can be replaced by computers to bring really the creativity and things that the computers cannot do it now. So I really think that you're going to be working side by side with computers, big data, and are going to be bringing the creativity to design those systems and to operate those systems in a different way that you do today.
Great. Let's go back to some of these questions as we wrap up. Makerspaces, and I think I'll give a general answer related to the school, but I think you want to jump into. There are dozens of spaces that students have access to related to their design teams, also related to the classes that they take. Hands-on work will be permeated throughout your 4 years. And also we just finished building the first section of the brand new Bomb Maker Family Space, which is, or Bomb Family Makerspace, which is actually pulling in lots of different teams into a full collaborative space. So makerspaces have been at USC long before the term makerspaces was ever used. It's just become very vogue now. These are lab spaces, and we have these everywhere, and specifically in civil and environmental engineering, there's a lot of stuff to do. I mean, I can think of environmental engineering taking up multiple floors in Beagler Hall. We've got all of the structural labs down there in Caprillion Hall. It's breaking stuff, it's loud noises, it's lots of cool things going on, lots of machinery you've never seen. Anything you all want to add into that?
No, we have both curriculum and extracurriculum activities that the students have to make things. You have the ASC competitions, the concrete canoe, the steel bridge that doesn't exist anymore because ASC had an issue with that. But several of those competitions that you have teams of students participating and competing, you have a lot of hands-on through labs, classes, and at the same time now you have a lot of entrepreneurship and things that the students are building through classes, using the Makespace. You have a class that it's very famous that we send our students to Lesbo Island in Greece, and the students were trying to build things to improve the life of refugees. So from those, I think that you have now, from the last 3 years that you offered that class, you have 7 startups that started at the department to improve the quality of life of refugees. So all the students build the prototypes and things with their own hands.
So we need to wrap up because I know I want to be respectful of everybody's time. We're not going to be able to get all of these questions. And so if you asked a question, you want to follow up with us via email, happy to help you. A couple quick notes. Ashwini, your question related to students and women of color. You should understand that we have actually brought in the most diverse class in the history of the engineering school this year, specifically historically minoritized students in undergraduate engineering programs. Black, Latinx, and Native or Indigenous peoples are one of the highest numbers, more than double most of the nationwide averages, 9% Black, 20% Latinx, 1.1% Native American. This is an incredibly important dynamic, and diversity is key to our undergraduate student body. You can learn more about all this and more, especially a lot of these questions related to careers and career placement, where our students are very successful, specifically in civil, and there isn't a harder or easier way to get a job based on one of these degree programs. At the end of the day, it's a civil engineering degree, it's an environmental engineering degree. Don't let the specializations trip you up anyway. Those are just ways to kind of expand on your ideas and expand on your passions inside of the discipline. You don't change your job prospects necessarily because of that. So realize that students are successful in all of these programs. Is there anything else you would all like to say before we wrap up, and then we can close it out?
Oh, that I'm just looking forward to see you all in the next few years.
Yeah, absolutely. Make sure you apply.
On campus, not on Zoom.
Yeah, let's get over this with the Zoom stuff, right? Yeah, as quickly as possible. I'd really like to do that. But yeah, don't forget to apply, everybody. The application process is open now and due by December 1st if you want to be considered for merit-based scholarships, and all of you do. So thank you so much for coming. Thank you, Dr. Childress. Thank you, Dr. Gensturk. Thank you, Dr. Van Weiss, and thank you, Dr. Swigelman. We really appreciate you coming. Have a fantastic evening. And now I'm going to go get some dinner ready with my family. Bye, everybody.
Bye.